Topic 12, Solve Problems Involving Volume, Part 2. In Part 1 of this lesson, you learned about cylinders. In Part 2, you're going to learn more about cones and spheres from Lessons 12.3 and 12.4. Lesson 12.3, Find Volume of Cones. In this lesson, we're going to use what we know again about circles, but this time to find the volume of a cone. A cone only has one circle shape for a base, and then comes to a point where the edges meet. In this lesson, the main piece of learning that we have is how the volume of a cone relates to the volume of a cylinder. And you'll see that right here in the middle of example 1. The volume of a cone, or the space that it takes up inside a cylinder, is 1/3 the volume of that cylinder that has the same height. So instead of using pi r squared h to find the volume of a cylinder, we're going to take that number and divide it by 3. Because remember, 1/3 of something means to divide it into 3 equal parts. Now let's take a look at the try it question. Find the volume of the cone. Use 3.14 for pi. So you'll notice here that they start out with a formula and they've got some empty boxes for us. So the first thing that we need to do is we need to find the radius and the height of that cone. The 1/3 is the piece that was missing from that first box because that formula says volume is 1/3 times pi r squared times h. So 1/3, the area of the circle is pi r squared, and h is the height of the cone. So we've substituted in the second line for pi, 3.14, and then we have to find the radius, which we're going to square. In this case, the radius is equal to 1 5/10. Then we're going to multiply that all by the height, which is 4. After we square the 1 5/10 and we get 2 25/100, we're going to multiply everything together. So the easiest way to do that is to multiply these pieces first, and then we're going to take 1/3 of that number. So let's do our pi times 2 25/100 times 4, and we get 28 26/100. Now, remember, multiplying that by 1/3 means to take that number and divide by 3. And when you do that, you get 9 42/100. So that's what should have gone in that box here. And in this case, we're talking about inches, so the volume of that cone is 9 42/100 inches cubed. We're going to skip over examples 2 and 3 because in this lesson, I just want you to learn how to apply the formula for finding the volume of a cone. If time permits, then we'll come back and learn about other problem solving that we can do in order to find missing measures in the cone or to solve additional problems. Remember, finding the volume of a cone is simply taking 1/3 of the volume of a cylinder that has a same radius for a base on the circle and the same height. In other words, you could take the volume of a cone as pi times radius squared times height, and then divide by 3. And you'll see that right here. So take the result of all that multiplication and then divide the answer by 3. Let's practice with a couple of questions on the next page. Question 8 asks us to find the volume of the cone to the nearest hundredth. So I'd like for you to substitute in your numbers, go ahead and calculate, and then come back and check your answer and see if you got the same thing that I did. All right, go ahead and check your work and check your answer. And if you have questions, please ask. We are going to do some problem solving here in question 12. A water tank is shaped like the cone shown. How much water can the tank hold? So how much can it hold is a question about volume. So we're going to use 3.14 for pi, and we're going to round that answer to the nearest tenth. So go ahead and do that, and then come back and check that part of your answer. The volume of this tank is 7,598 and 8/10 cubic feet. For part B, it asks us to think about if water is drained from the tank to fill smaller tanks that each hold 500 cubic feet of water, how many smaller tanks can be filled? Well, we need to find out how many times 500 goes into that amount. So we're going to divide that volume by 500, and we see that we get a decimal number. So how many smaller tanks can be filled? 15. Now you're ready to try a few problems about cones on your own. Next, let's go on and talk about spheres. Lesson 12.4, find the volume of spheres. In this lesson, we're not going to actually do the problem solving that comes along with this, but just to focus on using that formula to find the volume of a sphere. Remember, a sphere would be something like a basketball, a tennis ball, a golf ball, anything that is rounded in shape and is the same distance from the center of that three-dimensional shape to any point along the outside of that edge. Look carefully at example 1 and read through the problem. Then we'll talk about how the formula for finding the volume of a sphere comes about. Since the volume of a sphere is twice the volume of a cone, we can use the relationship between those two in order to find the volume formula. So you'll notice here in the example in the middle that we have the volume of a cone right here. So this is the volume of the cone. We're going to do that volume 2 times. That's the 2 in the front. So they've expanded that volume formula here to show you that the area of the base, remember, that B, is pi r squared. And then you're going to multiply that by the h number, which is, of course, still representing height. Now, on a sphere, the height goes from the top of that sphere all the way down to the bottom of the sphere, okay? So you have here a height which is actually the same thing as its diameter. It's twice the distance from the center to the top and then the center to the bottom. So in this sphere, in this example from the gumball machine, you have a height which is equal to 12, and the radius of that sphere is equal to 6. Okay, and when you multiply those number portions together, okay, the height is 2 times the radius, okay, the diameter, and then you have a 2 on the outside, so all together, 2 times a third times the 2 in front of the r, you have 4 thirds, and then you have your pi r squared here, and another r over here. So you have 3 r's, so radius cubed, times pi, and then times 4 thirds. So here's your volume formula, okay? This is the one that we're going to be using throughout this lesson. Now let's go ahead and try it out with the try it question at the bottom of your page. What is the volume of a ball with a diameter of 6 centimeters? So here we've got 4 thirds pi r cubed. That's our volume formula. So the diameter is 6 centimeters, which means our radius is half of that, or 3 centimeters. So here we're going to use a 3 for the r number. Now, 4 thirds times pi times 3 cubed means we're going to do 4 thirds times 3.14 times 3 to the third power. Now remember, 3 to the third power isn't 3 times 3. It's 3 times 3 times 3 again, which is 27. Now multiply those out and tell me what you get. Now, did you remember how to multiply 4/3 times the rest of the numbers? Remember that when you do 4/3 times those values, it's like multiplying all of your top numbers together, and then you're going to divide by the 3 that's on the bottom. So 4 times pi times 27, and then divide that by 3. That's how you're going to get to the last step here, which is 113 4/100 centimeters cubed. So the volume of the ball is about 113 cubic centimeters. Just as in the previous lesson, examples 2 and 3 are more application questions that require multiple steps and multiple formulas in order to solve them, such as using surface area to find the radius of a ball or of a sphere, and then use that radius measure and then to find the volume. We're going to go ahead and skip these 2 examples and go to a couple of practice problems just to try out your use of the formula. For this lesson, we're going to focus on the 2 questions in the assessment practice piece at the end of lesson 4. So don't forget, here is your volume formula. So this is how you'll normally see it written. Okay, volume equals 4/3 times pi times radius cubed. But the other way you can think about it is how you actually calculate, which is doing 4 times pi times radius cubed, and then divide by 3. So let's take a look at question 16. A spherical boulder is 20 feet in diameter and weighs almost 8 tons. Find its volume. Well, the first thing that I noticed here is that there's a piece of information that's really not needed. So which piece of information is mentioned in the first sentence that you don't need in order to find volume? Weight. You're right. Weight is not applicable here, so we don't need that piece of information. But what we do need is we need to have the radius of the sphere or of this boulder, which is just another name for a big rock. Okay, since it says it's 20 feet in diameter, that means the radius is half of that measure, or 10 feet. So that's the number we're going to use in place of radius in our formula. So go ahead and set up your formula, calculate the volume of the boulder, and then come back and check your answer. When calculating, you end up with a repeating decimal answer. It does tell us to round to the nearest whole number after using 3.14 for pi. So as a whole number, we get about 4,187 cubic feet. Now let's take a look at question 17. A bowl is in the shape of a hemisphere, which is half of a sphere. It has a diameter of 13 inches, and they want us to find the volume of the bowl. So we're going to still use our 3.14 for pi, and we're still going to round our final answer to the nearest whole number. We don't want to do any rounding prior to that unless we absolutely have to. So the first thing that we'll do is we will start with our volume formula. The volume of an entire sphere is 4 times pi times radius cubed, but they didn't give us a radius again. Remember, they gave us a diameter. So the radius, oops, my pen stopped working there. Let's try that again. The radius is 6 5/10 or 6.5 inches. Okay, so we're going to use 6.5 inches and we're going to cube that. This gets divided by 3. Now remember, this is the volume of the entire sphere. So this would be if I had a bowl that was entirely rounded all the way around. But this is not. This is a hemisphere, which means it's half of that. So after I get the volume of the entire sphere, I'm then going to divide that by 2 because I only have half of a sphere that makes up that bowl. Okay, it'd be like cutting a sphere in half and then taking it and creating a bowl out of the bottom part. So let's go ahead and calculate the volume of the entire sphere, and then we'll cut it in half. All right, do that part first and then come back and check that piece of your answer. All right, and one of the things that I notice is when I put this in the calculator, my calculator filled up the display, which means I have a decimal here that likely is repeating, and because I see the 3's here at the end. So I'm just going to leave that number in my calculator, don't clear it out, and I'm just going to hit divide by 2, and then we'll worry about rounding this next answer. So I get 574. And then 881,667. And I assume that this is also a repeating decimal with the 6's and then it rounded the 7. But it doesn't matter because our job is going to be to round to the nearest whole number. So we look at the 8 and the 8 tells us that this is about 575. So we're going to round that up in inches cubed. So that is the volume of that bowl that is half of a sphere. So we took the volume of the entire sphere and then we just divided by 2 to get half of that amount. Okay, so now you're ready to try a couple of questions on your own. If you have questions for me, please let me know before you get started on your work.